You know, 1 million EV connected simultaneously to the grid would be the equivalent in power to 2 nuclear power plants or 5 new generation gas power plants. So we are talking here massive power.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts, and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth-Haydock. As the world moves towards a more sustainable future, electric vehicles are becoming increasingly popular, and the need for efficient and reliable charging infrastructure is growing. Vehicle-to-grid technology offers a solution that not only meets the energy needs, but also benefits the electrical grid and helps reduce carbon emissions. It also opens new business opportunities. So let's dive into the exciting world of electric vehicle charging and see how it's shaping our future. I'm very excited to have Henri Trintignac, CEO of Gulplug, on the show today to talk about EV charging. Your company has developed a hands-free charging system for electric vehicles called Self-Plug, but your solution is about more than just fast and efficient charging. It's about connecting cars to the energy grid. But maybe I should let you explain a little bit more and introduce yourself. Welcome, Henri.
Thank you. Energy infrastructure is the more capital-intensive industry, and there will be hundreds of billions that will be invested every year in the next decade to produce, store, and distribute electricity. Mm-hmm. What is the limiting factor to transition from carbon industries to electricity will be our capacity to invest. Mm-hmm. There is an existing storage capacity that is known by everyone, and that has never been used so far. This energy storage is at scale, it is controllable, available now, could be mobilized within seconds, and is underutilized. And furthermore, this capacity is spread all over the territory, close to where power is needed. This capacity is the battery of the electric vehicle. Mm-hmm. And definitely making such a big storage capacity available as a service would greatly reduce the need for investment to transition from carbon energies. Mm-hmm. But so far, it is not working.
Why is that?
Basically, 80% of EVs are not plugged to the grid every day. Mm-hmm. In other words, if we plug EV once a day and for hours, if I plug my car when I drive back to home and let it plug for the whole night, this capacity can be used and it is at size and it is available. But people are not plugging their car, and the only way to make it is to have it plugged automatically. Mm-hmm.
So basically people, they use the charging like they use the petrol station. They just fill it up once it's empty, but they're not plugging it in every day, even if the battery is full.
They have not yet changed the usage they made of their car. Mm-hmm. So they fill the battery like they used to fill the tank of their petrol car. Absolutely. Mm-hmm. 1 million EV connected simultaneously to the grid would be the equivalent in power to 2 nuclear power plants or 5 new generation gas power plants. So we are talking here massive power.
That's incredible. And if I have done my research right, I read somewhere that for the European Union, they want to have 30 million electric vehicles on the road by 2030, that is in 6 years.
Yeah, 2030, 2050, 2035, it could be even 50 million.
Wow.
So if we take, let's say, the example 2035, the EVs may represent up to the equivalent of 100 new nuclear power plants.
Wow. And why is nobody using that yet?
Because EVs are not connecting every day. So if an EV is not connecting every day, then the storage capacity that can be used can be allocated by this EV is low and unpredictable. Mm-hmm. If it is connected automatically, then the storage capacity is, as an average, multiplied by 10 and predictable. And this is this that makes a business like storage as a service economically viable. Mm-hmm. So the challenge of the automatic connection is really there. Not only giving comfort to the user, yes, for sure, but for us, it is a key factor of success to transition from carbon to electricity.
If I understand it correctly, and this whole concept of vehicle to grid meaning that the system where electric vehicles can provide power back to the energy grid, to the electrical grid that we all use in our households as well. But have I understood it correctly that at the moment not every electric vehicle is equipped to give power back to the energy grid, and this is where your solution at Gulplug comes in?
Well, only a minority of EVs that are on the road today can do either vehicle to grid or vehicle to home or whatever, meaning they can get energy back to the grid from their battery. In the near future, car makers will equip their car with the vehicle to grid capacity. Mm-hmm. So this is necessary to achieve the goal to store massive energy in the electric vehicle batteries.
The car connect to the grid. Is it a problem implementing smart grid technology for EV charging management? What needs to be considered here?
Well, to get the maximum benefit of this technology would imply to change the battery charging strategy. Mm-hmm. So meaning use the battery on a limited range and connect the EV to the grid for hours every day, use the battery capacity on a limited range, and allocate part of this range for the mobility of every day, for commuting, and the rest of that range for storing energy. So to charge from the grid and to send back the energy to the grid. Mm-hmm. And it is by connecting plus changing the battery strategy that we can achieve to multiply by 10 the exchange of energy between the grid and the car every day.
And is the energy sector ready for that? I'm sure you have to scale up or change the infrastructure that many cities or countries are implementing now.
No, the main changes are how to plug the car and within the car. Because in terms of energy flows, you can re-inject energy close to where you need energy. So there is not a big impact on the distribution system of electricity. And this is the beauty of the thing. I mean, it's not only less investment in terms of storage, but it is also less investment in terms of distribution. Mm-hmm. Because this capacity is spread all over the territory. Well, when you get back to home, first thing you do, you park your car. Then it is connected automatically to the grid. You enter home and you switch on the light. So you need energy when the car is already connected.
So this is probably then something where the user needs to change how he uses his or her electric vehicle. How do you ensure user convenience and the experience in EV charging, such as payment systems, network access, or even incentives to do so?
So the system we have developed is based on part of the system is within the car and part of the system is directly connected to the grid. Mm-hmm. This part of the system is connected also to internet. So it's kind of a gateway between the car, the grid, and internet. And somewhere you have an operator that will manage the charging of the EV.
And do governments play any role at this? I'm, of course, now thinking from a German perspective, but since this probably has to work cross-border, and I'm sure that in France, this is at least what I believe. I have the feeling you're a little bit further down the road already and a little bit more innovative in that field. What roles do governments play in this scenario?
I would say, honestly speaking, I don't know. I see more people like energy management solution provider or utilities or car makers involved in this rather than governments.
Okay.
Governments, at the end of the day, they are stakeholders. They will benefit from it, definitely, because it will accelerate the energy transition. So the benefit will be also for the governments. But I don't see government that much important in this loop.
So we have talked a little bit about the challenges, scaling up the infrastructure, bringing users to change their behavior. What opportunities do you see in this vehicle-to-grid solution? There are business opportunities. I think you have touched on the energy sector that should be interested in this, but there should be also more business opportunities even for car makers, I suppose.
Yes, car makers. Definitely, they are in the loop. And I would say they are kind of a cornerstone in the loop. Why? Because they have the direct link with the customer, the user of the car. Most likely, they will also own the car and the battery, and they will have the data on the battery. So they are really in the middle, in the loop. For the benefits for them is, number one, having an automatic connection means they can give a positive answer to the main users' objections that are still range, charging, and affordability of EVs. They can also upgrade their business models from selling a vehicle, like they do today, or to selling package such as mobility as a service, which is a package of a vehicle plus energy to get for mobility, And they can also be part of this storage as a service. So for them, it's a great opportunity. And on the longer term, they can also have positive impact on the total cost of ownership of their car. Make it simpler, have a battery lifetime that is longer, and adding new revenues. And all of that will contribute to lower the total cost of ownership of a car, meaning the third objection of user will be answered.
So it seems that vehicle-to-grid seems to be the superior EV charging strategy for the future. Is there a catch? Is there also a downside to all this?
There is not yet standards. There is still work to be done to make vehicle-to-grid acceptable from utilities' point of view. So there is still work to be done. But we are more and more, all the stakeholders are, I would say, conscious that there is a big impact of V2G and they are going together. If you want to have the maximum benefit from vehicle-to-grid, you need the car to be connected. And if you want the car to be connected, it has to be connected automatically.
This podcast was brought to you by Avnet Silica, the engineers of evolution. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or avnet-silica.com. That's avnet-silica.com. And I suppose you need a lot of charging points. I'm not sure if you have more accurate numbers than I have. I read somewhere that I think in the European Union there are 200,000 public charging points at the moment. And I think by the time we are aiming for 30 million vehicles, I read somewhere that we actually would need over 1 million more charging points.
Yeah. Well, we have to realize first, close to 90% of the energy that will be used in an EV lifetime can be delivered at home. So, and here, automatic charging and V2G is much more on home charging rather than in-street parking charging. So our first market is home charging. And we believe there is 2/3 of the cars in Europe have or can have easily an allocating parking space, meaning when you drive back home, you park your car always at the same parking space. And what we target is to equip this parking space, so 2/3 of the cars, with automatic charging. Then after, we will go for in-street and public parking.
Okay, understood. So that gives you a little bit more time to scale and prepare.
Yeah, absolutely. We are talking here a huge market. There is in excess of 1 billion cars in the world. And our vision is that sooner or later, all EVs will be automatically connected to the grid as soon as parked. So we are dealing here with a huge market, which is estimated for our automatic charging device, hands-free charging system. It's a market that is estimated over 500 billion euro. And we are starting with home charging for cars that have allocated parking space, which is 2/3 of the total number of cars. To go the next step, then we need kind of standardization. Any car can park and connect to the grid automatically at any parking space. And this will take some time. Standardization is ongoing. We do believe that standardization is going, I would say, same speed as we develop our products. We are not the only one on the market. And at the end of the day, we believe the standard will be driven by volume. So the solution that will have the biggest volume will drive the standard. We are aiming a market that is original equipment of cars, of new cars. Our customers are the car makers, and we are targeting first the top car makers. We are targeting volume markets rather than niche markets.
Yeah.
Because our vision is V2G will be beneficial only if cars are automatically connected.
So this is basically also your prediction for the future of EV charging for the next 5 to 10 years, so that big car makers will adopt the system and then you can go broad and drive the transformation to a vehicle-to-grid solution.
Yes.
Cool. That sounds very interesting. You mentioned that there's still work need to be done. So when do you think we will see the first cars charging on the parking spots?
I would say first cars that will be automatically connected to the grid with our systems, 5 years. And then maybe another 5 years to have them automatically connected everywhere in street or on public parking.
Exciting. Now, when we're talking about electric vehicles, are we talking passenger cars or are we also talking public transport?
We are mainly talking passenger cars or light commercial vehicles. The requirements for other kind of vehicles are different. So the solution can work, but not for all usage. So, if I take an example of a bus, a city bus, our system would be okay for overnight charging. But it won't be okay if we are talking for coach that is doing long distance every day and needs to refill his battery in half an hour.
Oh, yeah.
The system has not been designed for that. We are definitely aiming overnight charging with low power or medium power, not fast or ultra fast charging.
What do you think the trend of urbanization, more people moving to the cities becoming mega cities in the next couple of years, how does that trend impact the strategy? My point of view is that out of the window and I see no parking spaces at all. I don't see a lot of electric charging stations.
If you have a parking space at all, no problem.
Yeah.
If you don't, it's a problem.
Yeah.
And I don't think that public charging, as it is done today, is the solution to this problem. If you drive back home after work, then you connect your car to the public station, and you need to get back to the car 4 or 5 hours after. Then, because the operator of the public station, they don't want you to leave your car there for an eternity. They want to pay back on their investment. So meaning, midnight, you would have to go back to your car, drive it, and find a parking place somewhere. It's silly. It will not fly, never.
Yep.
Meaning, you need other revenue streams, and energy storage is one of these energy streams. But today, the way it is made, it will never fly. Who will accept to invest money and to have their public charging station that is used by a car for an eternity that is not charging anymore, that is not making money? So you have no payback on your investment.
Yeah. And at the same time, again, I have to speak for Germany. I'm not sure if I think it's different in France. We don't have the storage yet to save excess energy from renewable energy sources.
Yeah, but with our solution, the EV is no more the problem. The EV is the solution.
That's super exciting. I really hope this will...
You can store energy from the renewable in the EV battery. Today, every time you spend €1 in renewable production, you need to spend another €1 or €2 or €3 in storage and in distribution infrastructure. With this solution, you can save money both on storage and distribution, meaning our capacity of investment is limited. You can speed up the deployment of production. This is the beauty of the thing.
What would you say is a common myth about your job or your field of expertise?
I'm not sure that range or autonomy is the key thing in an EV. Almost 1/4 of vehicles that are used in Europe are just used for commuting, never for long range. Those cars, they don't need a big battery. They don't need either a big power, a charging power. So there is cars that are more versatile. They are used not only for commuting, but for some long range. Those cars will need more storage capacity in their battery, and they will need to be compatible with ultra-fast charging. So we have to accept first that some cars will not be usable for long range. And for those that we will use even for long range, we will have to accept minor changes in terms of usage, meaning stop every 2 hours or 3 hours for 15, 20 minutes.
Yeah, I've never thought about it this way. Range always comes as the first argument. That's correct. But when is really the time when you do need this kind of range? Yeah, you're absolutely right.
As an average, a European does something like 33 kilometers a day.
Wow.
And it's only a few long-range trips, maybe 2, 3, 5 maximum a year. And 25% of cars in Europe will never make a long-range trip. Never. Only commuting.
Yeah, that's what everybody wants. Long range, the longest range.
And today there is a dream or a myth that is long range, big batteries, high power. And this kind of myth may kill the EV because long range, big battery, high power means lot of weight, very expensive in terms of cars and in terms of infrastructure too. So for us, long-term vision, we believe in terms of charging, we need low power charging, overnight charging at home, then in street and in parking space, and ultra fast along the highways and motorways.
Then thank you so much, Henri. This was very exciting, very interesting. I've learned a lot about EV charging, and I think I also have to reframe my mindset a little bit when it comes to electric vehicles.
Have a good day. Bye-bye.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.